having the sun as your neighbor is hard. Searing hot temperatures, deadly radiation, and the onslaught of meteor collisions don't exactly make it the most welcoming part of the solar system. As you can imagine, these challenges make Mercury a particularly tricky place to get to. For this reason, even though it's much closer to us than Jupiter or Saturn, Mercury remains relatively unexplored. Still, scientists managed to send 2 different missions out to study Mercury. Mariner 10 flew by in the 1970s, followed by NASA's Messenger in 2015, which was the first probe to ever successfully orbit the planet. And now, as I speak, a 3rd Mercury mission is hurtling through the constellation of Pisces, over 177 million kilometers away from Earth. BepiColombo, a labor of love between the European Space Agency and the Japanese Aerospace Exploration Agency, is set to arrive on December 5, 2025. It will carry out a comprehensive study of the planet's magnetic field, surface, and internal structure. But, as they say, the journey is the destination. And BepiColombo's journey is a long one. Join me today as we reveal what BepiColombo has captured of Mercury so far, why it's traveling farther than the distance to Pluto to get there, and what we are hoping to learn about the closest planet to the Sun. If it were up to you, would you be curious about the secrets hidden within this blazing world? On October 20th, 2018, BepiColombo took off from the French Guiana Space Centre, beginning its 7-year journey to Mercury. Its trajectory would take it around the Sun 18 times, including 9 planet flybys. The first was an extremely close flyby of Earth on April 10th, 2020. BepiColombo came within just 12,700 kilometers of our planet's surface, about the distance from Copenhagen to Santiago, Chile. Its journey will then take it on 2 flybys of Venus and 6 of Mercury, the last 3 of which are due to happen in September, December, and January of next year. In total, the mighty spacecraft will cover a distance of 8.5 billion kilometers. Taking such a long route was the only way BepiColombo could slow down enough before approaching Mercury's orbit. But why is slowing down so important? Well, if the spacecraft arrived with too much speed, it would swing right past the planet and get sucked into the Sun's powerful gravitational field instead. BepiColombo was designed to complement and deepen the findings of its predecessor, the Messenger probe. While BepiColombo carries many of the same instruments as Messenger did, it is equipped with higher caliber tools able to obtain larger ranges of data. Additionally, Messenger's orbit of Mercury was rather one-sided. Its periapsis was over the South Pole, meaning we have great detail and mapping of the Northern Hemisphere, and almost non-existent data on the Southern Hemisphere. Do you think this time, BepiColombo will finally complete that missing piece of the puzzle? BepiColombo plans to rectify this by examining Mercury from an orbital angle more in line with the planet's equator. BepiColombo is a very unique spacecraft. It's made up of 3 component parts, 2 probes and a propulsion module, that were launched and traveled together in a united configuration known as the Mercury Cruise System. Run by ESA, the Mercury Planetary Orbiter, or MPO, will study the planet's surface and interior, while JAXA's Mercury Magnetospheric Orbiter, affectionately known as MEO, will study the planet's suspiciously low magnetic field that has baffled scientists for decades. The name MEO was actually chosen by the Japanese general public. It means a waterway, and according to JAXA, it symbolizes the scientific milestones reached so far and wishes for safe travels to come. MEO and the MPO sit on either side of an interplanetary propulsion unit called the Mercury Transfer Module. Stacking the different parts of the craft together like this means most, but not all, of the scientific instruments on board will be inoperative until BepiColombo settles into its orbit around Mercury. At that point, the MPO and MEO will be jettisoned from the spacecraft and go their separate ways to study Mercury from different vantage points. But don't worry, there's still enough data being sent back to keep us entertained. Why don't we take a look back at how far this mission has come, what it's already taught us, and explore some of the amazing things it's seen along the way. BepiColombo's first encounter with Mercury came in October 2021, passing just 200 kilometers above the planet's surface. It sent back some stunning images. As it drifted past, BepiColombo snapped Mercury's northern hemisphere. These images are not only visually striking but also offer valuable data to help scientists better understand the planet's rugged terrain and ancient scars. To the average person, it might look like our rocky, inert moon. But the trained eye sees the Calvino Crater, which could hold the key to deciphering Mercury's crust composition. The Lermontov Crater hosts traces of volcanic activity and mysterious pockets where an unidentified compound in the planet's crust is being lost to space, and scientists have no idea how or why. These initial images remind us just how enigmatic Mercury is, and how much we have left to learn about it. Another camera, mounted on the spacecraft, caught Mercury from another perspective, one that left the planet's volcanic history on full display. Previously lava-flooded and over 250 kilometers wide, the Guiana Crater comes into view, along with the Pampu Facula, one of Mercury's many bright spots probably formed by volcanic eruptions from billions of years ago. Even though Messenger had already shown us Mercury's volcanic past, it's still pretty amazing that this activity left a mark visible after such an inconceivable amount of time. And BepiColombo didn't just show us how the flyby looked, it let us feel it too. You know how your phone has an accelerometer that tells it when you tilt or move it? Scientists installed a similar accelerometer on BepiColombo's MPO. It measured the spacecraft's movements and vibrations as it flew past Mercury, creating a sort of sound map of the flyby. Then, they converted that data into frequencies that humans can actually hear, so you can quite literally hear the encounter. What would it be like if we could one day hear the voices of the planets? BepiColombo captured magnetic field data during its flyby that was also later deciphered and sonified by scientists on the ground. This one is a little more abstract than the other one, but we'll give it a go. You're going to hear two synthesizers at the same time. The first synthesizer changes pitch with the changing magnitude of the background magnetic field. A lower pitch means stronger intensity. The second synthesizer shifts pitch based on the variations in the magnetic field. A more turbulent magnetic field is represented by faster changes in pitch. The dotted vertical line shows where the closest approach happened. After that, you'll hear something like a DJ scratching a disc. Lots of rapid pitch shifts. That's when the spacecraft crosses the magnetosheath, where the magnetic field becomes highly turbulent. Let's have a listen. On June 23, 2022, just over halfway in its planned journey, BepiColombo crossed paths with Mercury once again. This time, the spacecraft turned its gaze toward Mercury's largest impact crater, the Caloris Basin. At a whopping 1,550 kilometers wide, it's actually one of the widest known craters in our solar system. Caloris Basin was likely created by the collision of a comet, asteroid, or other celestial object some 3.9 billion years ago. The highly reflective lava craters on its floor make it easy to see as the bright semicircular area of Mercury's disk, just below the magnetometer boom. The second flyby gave us beautiful images of Mercury's craters like we'd never seen before. Like this one of Enoch. a crater embedded in smooth volcanic plains, potentially near an ancient volcano which BepiColombo plans to examine when it finally settles into orbit. Almost exactly a year later, on June 19, 2023, BepiColombo reapproached Mercury from a height of just 263 kilometers. The flyby images captured the 600-kilometer-long Beagle Rupes, one of many lobate scarps on Mercury that was first imaged by Messenger in 2008. Other than our Moon, Mercury is the only planetary body in our solar system known to exhibit this tectonic signature. When the interior of the planetary body cools, it leads to a global contraction and surface expression of a thrust fault, also known as a lobate scarp. Beagle Rupes has an especially pronounced curvature, more so than other scarps on Mercury, offering geologists a rare insight into the planet's tectonic history. As a result of the third BepiColombo flyby, a large 218-kilometer-wide peak ring impact crater received the name Manly, after 20th-century visual artist Edna Manley. The original basin floor was flooded by lava, giving the crater its visibly smooth interior texture. BepiColombo will explore Manly Crater further from orbit, seeking to measure its carbon composition and detect any other minerals that may be present, in order to learn more about Mercury's geological history. Gliding past Mercury on its most recent flyby, BepiColombo snapped a series of farewell Mercury images. At 236 kilometers above the surface, BepiColombo appears to hug the planet goodbye. Scientists back home on Earth will have to wait another 16 months for the next set of images. If you only had a few moments to say goodbye to a planet, what would you choose to capture? Now, these flybys are more than an indulgence for our senses. They also revealed important nuances of the planet's particle environment and magnetic boundaries. One of the instruments aboard the MPO probe is Phoebus, probing of Hermian exosphere by ultraviolet spectroscopy. Phoebus uses UV emission from Mercury's exosphere, the planet's outermost and only atmospheric layer, to determine its composition, structure, and interactions with the surface. It does this by detecting specific types of light emissions in the ultraviolet spectrum, ranging from 55 to 315 nanometers. By capturing these light emissions across the whole spectrum, it helps us figure out what the exosphere is made of and how its particles are spread out. As BepiColombo emerged from Mercury's shadow, Phoebus detected the presence of hydrogen and calcium, confirming earlier findings from Messenger that established the presence of calcium in the planet's exosphere, particularly around the equator, and on its night side. Interestingly, this is the opposite of the distribution observed for sodium and potassium, which more readily concentrate around the poles. Once in orbit around Mercury, Phoebus will be able to send back much more detailed analysis of Mercury's exosphere composition and dynamics, including how it changes with location and time. Speaking of Messenger, back in its day, it discovered ice on Mercury's North Pole. BepiColombo will continue this legacy by continuing the search for ice in permanently shadowed regions of high-latitude craters. As you might know, Mercury is the only planet in our solar system to have a magnetic field similar to Earth's. Thanks to its liquid iron core, Mercury exhibits a dynamo effect, which creates an innate magnetic field around the planet. However, Mercury's magnetic field is just 1.1% that of Earth's magnetic field, leaving scientists fascinated with how it's generated. One of the big goals of the BepiColombo mission is understanding this magnetic field better. So far, only the magnetic activity of the Northern Hemisphere has been mapped by NASA's Messenger mission. Scientists hope that BepiColombo will be able to shed light on the dynamics of the planet's magnetism in the Southern Hemisphere. This magnetic field is of great importance. By understanding it, scientists aim to uncover clues about Mercury's origins, its evolutionary journey, and the current state of the planet's interior. MPO and MEO will travel through different areas of Mercury's magnetosphere on different timescales, simultaneously measuring how the magnetic field changes over time and space, and its relationship to the powerful solar wind. All this new data from the BepiColombo mission will eventually be compared with global magnetic field models from the Messenger mission to build the most accurate picture yet of Mercury's magnetic field, a picture that could unlock telling insights into the planet's elusive past. As we await BepiColombo's next Mercury flyby in September 2024, the journey to understanding Mercury continues. The spacecraft is preparing for its next major maneuver, a prolonged solar electric propulsion, thruster arc, planned from early August to mid-September. These arcs, combined with strategic flybys, allow BepiColombo to slow down against the Sun's immense pull, essential for entering orbit around Mercury. Once in orbit in December 2025, the real exploration begins. Mercury's heavily cratered surface records a 4.6 billion-year history of asteroid and comet bombardment, which, along with unique tectonic and volcanic features, can unlock secrets of the planet's role in solar system evolution, said ESA scientist Jack Wright. BepiColombo is set to orbit Mercury for 1 year, with the possibility of an extension. Scientists aim to study the planet more deeply than ever, from its composition to its geophysics, and from its magnetosphere to clues about inner planets like Earth. Thank you for joining us on this journey to uncover the mysteries of Mercury and the extraordinary mission known as BepiColombo. The universe is vast and full of wonders, and with each flyby, each captured beam of light, we take one more step toward understanding our place in the solar system. From ancient impact basins to the planet's fragile exosphere, from its faint magnetic field to the final glimmers of light as BepiColombo exits Mercury's shadow, everything tells a story we're only beginning to understand. The secrets of Mercury are also clues to better understanding Earth and the origins of life itself. If you found this video insightful and inspiring, don't forget to hit like, subscribe to the channel, and turn on the notification bell so you won't miss any of our upcoming adventures. Once again, thank you so much, and goodbye for now. We'll see you in the next video.